Welcome to G Fun Facts Online. Today, we are diving into a story that connects the deep history of our planet with the future of space exploration, all hidden beneath the surface of the Great Lakes. 80 feet beneath the surface of Lake Huron, a diver descends into a world that simply should not exist. The water above is the familiar, crisp blue of the Great Lakes, chilly and clear. But as the diver passes the rim of a submerged crater, the environment shifts violently. The temperature plummets. The water blurs, shimmering with a mixing haze known as a halocline. This is the visible boundary, where buoyant fresh water meets a dense, heavy fluid rising from below. Crossing this threshold is like stepping into a science fiction movie. The lakebed, usually a drab expanse of silt and invasive zebra mussels, is suddenly carpeted in a vibrant, pulsating mat of purple organic matter. Ridges and fingers of ghostly white filaments wave in the current. The smell, detectable even through a diver's regulator, is sharp and metallic. It is the undeniable stench of rotten eggs. This is not a pollution site. This is the Middle Island Sinkhole, a natural anomaly within the Thunder Bay National Marine Sanctuary. Here, in the heart of North America's freshwater seas, lies a functioning ecosystem that mimics Earth as it was 2.5 billion years ago. Even more rapidly, it mimics the conditions scientists expect to find in the subsurface oceans of Jupiter's moon, Europa, and Saturn's moon, Enceladus. These are the Michigan anomalies. To understand why an alien ocean exists in Lake Huron, we must look nearly 1 billion years into the past. This story begins with a geological event called the Mid-Michigan Rift Anomaly. Approximately 1.1 billion years ago, the North American continent began to tear apart. Magma surged upward, creating a massive rift system stretching from Kansas through Lake Superior. But then, the rifting stopped. The continent didn't split. Instead, the failed rift left behind a dense scar of igneous rock buried deep beneath the surface. As this heavy rock cooled, it sagged, creating a bowl-shaped depression known as the Michigan Basin. Over hundreds of millions of years, this basin filled with shallow, tropical seas. These ancient oceans left behind massive deposits of carbonates, limestone, and evaporites like salt and gypsum. During the Devonian period, roughly 400 million years ago, these layers were packed with marine life. But these rocks are soluble. When groundwater moves through them, it dissolves the minerals, creating a landscape known as karst. It is essentially the geological equivalent of Swiss cheese. In the Alpena region of northeast Michigan, this karst formation allows groundwater to permeate deep into the ancient, salty layers of the basin. The sinkholes in Lake Huron are not just holes where the roof collapsed. They are active vents. Groundwater travels through cracks, dissolving the ancient salts, becoming a brackish, sulfur-rich brine. When this pressurized water finds a weak point in the lakebed, it surges upward. The water emerging from the Middle Island Sinkhole is not lake water. It is ancient aquifer water, chemically distinct, and carrying the molecular memory of a 400-million-year-old sea. Now let's look at the Middle Island Sinkhole itself. It is the crown jewel of this research, located just a few miles offshore at a depth of about 80 feet. It is shaped like an hourglass with two main chambers. The northern chamber, known as the arena, is a vast bowl roughly 300 feet across with sheer limestone cliffs. Swimming over the rim is disorienting. The invasive quagga mussels that cover the rest of the lake floor vanish here. They simply cannot survive the chemistry of the pit. At the bottom lies the alcove, where the groundwater discharge is most vigorous. The sediment here isn't sand. It is meters-thick layers of decomposing organic matter. The water inside is a chemical anomaly. The temperature remains a constant 45 to 48 degrees Fahrenheit year-round, regardless of the season. It is hypoxic to anoxic, meaning it has little to no oxygen. Most fish entering this zone will suffocate. It is also loaded with sulfates and chlorides, but the critical component is hydrogen sulfide. This is what gives the sinkhole its rotten egg smell and serves as the fuel for the ecosystem. Because of the dissolved salts, this water is heavy, creating that shimmering halocline layer that traps the chemical soup at the bottom. But the most striking feature of the Michigan anomalies is the biology. The floor is carpeted in brilliant purple and white mats that look like velvet draped over the rocks. These are not plants, they are microbes. This ecosystem is dominated by two main types of bacteria locked in a perpetual, slow-motion dance. First, we have the purple cyanobacteria. These are photosynthetic, but they are adapted to low light and can use sulfur compounds. Their purple pigment allows them to harvest the specific wavelengths of light that penetrate the murky water. Second, we have the white chemosynthetic bacteria. These organisms do not need light at all. They derive energy from chemical reactions, specifically the oxidation of sulfur. For years, scientists were puzzled because the mats seemed to change color. Time-lapse photography revealed the answer: the mats are moving. This is called diel vertical migration. During the day, the purple bacteria migrate to the top to capture sunlight, burying the white bacteria and turning the floor purple. At night, the white bacteria, which rely on the sulfur-rich water rising from below, migrate upward to access the chemical interface, burying the purple bacteria and turning the floor white. This breathing of the mat is a survival strategy, and it has profound implications for Earth's history. Scientists believe this sinkhole is a modern analog for the shallow seas of the Proterozoic eon, billions of years ago. Back then, Earth's atmosphere had almost no oxygen. Cyanobacteria were the first organisms to hack photosynthesis to produce oxygen. Research here suggests that the slowing of Earth's rotation played a role in the Great Oxidation Event. Billions of years ago, days were short. As the rotation slowed and days lengthened to 24 hours, the purple phase of the mat lasted longer, allowing for a net release of oxygen that eventually terraformed our planet. These sinkholes are a working model of the engine that made Earth habitable. But if these sinkholes are time machines to the past, they are also telescopes to the future. NASA and astrobiologists have zeroed in on Thunder Bay as a critical analog site for exploring ocean worlds like Europa and Enceladus. Both of these moons have thick crusts of ice covering global oceans of liquid water. On Europa, beneath 10 miles of ice, there is no sunlight. Life there would have to be chemosynthetic, relying on chemical energy, just like the white bacteria in Lake Huron. The Middle Island Sinkhole offers a perfect low-fidelity analog. It has anoxia, sulfur chemistry, and cold temperatures. And crucially, it is accessible. Testing a robot in the Mariana Trench costs millions. Here, scientists can deploy a prototype in the morning and have it back in the lab by lunch. This has made the Michigan Anomalies a playground for advanced robotics. One standout is Orpheus, a class of autonomous underwater vehicle developed by Woods Hole and NASA's JPL. Orpheus is designed to explore the deepest trenches of Earth and eventually the oceans of Europa. It uses terrain relative navigation, scanning the seafloor to build a map in real time, which is essential when GPS is impossible. In the sinkholes, Orpheus trains to identify science targets, like the boundary between the bacterial mat and the rock, without human intervention. Researchers are also testing suction samplers that gently vacuum up the delicate microbial mats and coring devices to analyze the sediment. The goal is to miniaturize these labs so a robot on Enceladus could suck up a sample, sequence its DNA, and beam the data back to Earth. Just when we thought we understood the anomalies, a new mystery emerged in 2022. Researchers mapping the Wisconsin shipwreck coast in Lake Michigan noticed something odd on their sonar. In 450 feet of water, much deeper than the Alpena sinkholes, they found dozens of perfectly circular depressions. These holes appear in a line tracking an ancient geological feature. Are they sinkholes? Initial ROV dives confirmed they are craters, but the vibrant purple mats haven't been confirmed in the same density yet. They could be collapsed karst features fed by groundwater, potentially harboring life adapted to even higher pressures. Or they could be glacial scours left by waterfalls from the last ice age. If they are active vents, it means the Michigan anomaly isn't just a local freak occurrence, but part of a vast, interconnected subterranean plumbing system across the Great Lakes Basin that we are only just beginning to map. Initiatives like Lakebed 2030 aim to map the entire floor of the Great Lakes in high resolution, and scientists expect to find hundreds more of these features. The Michigan anomalies teach us a humbling lesson. We spend billions looking at the stars, yet right here in the freshwater heart of North America, we have an alien world that was hidden in plain sight. These sinkholes are the intersection of Earth's deep past and humanity's future in space. They are the only place where you can dive into a Proterozoic ocean and watch the mechanism that gave us the air in our lungs. And when we eventually look at the black oceans of Europa, we may well see the reflection of the Michigan anomalies staring back at us.